a lot of these 2D kinds of images, they're easily misinterpreted because sometimes they just look difficult, but then they're really not. So they say the inclination of the roof of a house is to be raised from its original inclination by 16. So the wall of the house is 6 meters. So you have the wall of the house here, which is 6 meters. The top of the original roof is 8. So meaning this is the original height. This is like 8. And then it says it's 8 above the ground. The width of the house is 12. So from here to there is 12. So meaning this is also going to be 6. And this is 6. And then it says, what you may call. The first thing before you even answer these questions, as we said here, if the original roof, right, is to be raised from its original, the inclination of the roof of a house is to be raised from its original inclination by 16. We said that this is where the original roof is. So if you raise it by 16, it means that this is the angle that's equal to 16. You see this angle here. That's the angle that's like 16 degrees. So what we also can see here is from all the information given, they said we should work out the equation of ED. So the one thing about ED is that, I mean, like this is definitely a 90-degree angle. The reason we know this is 90 is because this is like a horizontal line. It's line from straight. It's just going to be a straight line like that. So this is 90. Now we already know if this is 6 up here, this is going to be 6. If the whole thing is 8 and this part is 6, it means that this part is a 2. You see, all that information, we have to analyze it from the sketch. So as long as you have a right angled triangle with 2 sides given, you can always work out the angle inside that triangle. Or rather, I mean, like if you need the equation of DE. Whoa. Oh, wait, but this is on a Cartesian plane, you see, because I mean, like this is the origin, you see. So do you see you can get the coordinate of D and the coordinate of E, and then from there, you can then like get the gradient, and then you can also get the y-intercept. You see?
Yes.
Yeah, because so far, let me just crop this thing, because I think the one thing is as long as this is on the x-axis, I mean, or the Cartesian plane, it makes our life a bit easier, because all we need is the equation of any straight line. We get it by saying y is equal to mx plus c. Yeah, another way we can use is just y minus y1 equal to m, and then x minus x1, like that. And then what now? So from here, I think this one is usually easier, because all we will need here is a coordinate that the graph passes through, and then the gradient. But before we can do that, we can get the coordinate of D and E, because if this is the origin, you can see that the x value of D is going to be -6, because it's going to be 6 to the left. Do you see? Yeah, and then it's going to be 6 upwards. So this is the coordinate of D. For E, it's nowhere to the left or to the right. So the x value of E is a 0. And then the y value, it's like 8 upwards. So you have x, you can have 2 coordinates that the graph passes.
Where did I get the 12 from? Oh, no. Sorry. I just made a mistake.
Yeah, they said it is 12 meters wide. So with all that being said, we know that the gradient of DE, you're going to have to say y2 minus y1, x2 minus x1. And then you're going to have here, you can say here 8 minus 6. And then 0 minus the -6. It would be a plus. And then here you're going to have 2/6, which is just 1/3. That's the gradient of DE. So you have a gradient and you have a coordinate. You can use whichever coordinate you want. But the fortunate thing is here we already have the y-intercept. It's just the 8, you see. So we have a y-intercept and we have the gradient. So we don't even need to use this format. You know, we can just jump straight to this one. Because the y-intercept is a positive 8 and the gradient is a third. You see?
Yes.
Yeah, because of the y-axis there. If you wanted to do the long dry, you would still end up with the 8 here. Because if you went this route, you would have said y minus 1 coordinate. You can use the 6 there. Gradient is a third. And then x value here, you can put a positive. You can put a negative 6 there. You'd have a positive there because a negative times a negative gives a plus. And then if you multiply inside, here you're going to have a third times x, and then a third times 6. Okay, this one is kind of scary. Okay, it's not really scary actually, because you'd still have a third here. This is just a 2 plus 6.
True.
You have your 8 here. Same idea. You have your equation of your ED. Ka-ching. Yeah. So with question 2 and 3 now, they say calculate the inclination of the original roof with the horizontal. So the inclination with the original roof, you can already see how we have this right angle triangle here and this shape. So getting this angle, we can just use trigonometry because it's a right angle triangle, right?
Wait, I have just a curious question, right? In analytical geometry, is it possible to use the Pythagoras theorem?
Well, Pythagoras will get us the length of DE. So Pythagoras is to get lengths. But the thing with math is don't limit what you can use based on the topic. Any math topic, you can use whatever math knowledge you have to work out anything. Always. There's no ways you can say I'm doing analytical, so I cannot use something math related. You know, you're just going to yeah. If you're going to thingy, if you're going to what you may call do anything in math, anything works as long as it's going to help you work out what you need to work out.
Okay.
So let's see, 2 and 6. So yeah, I mean, like, to get the angle of inclination there, you can just use normal trigonometry. This is like 2 degrees, I mean 2 units, 6 units, and you're looking for this angle. So it's opposite and adjacent, which is tan. Tan, the angle, is gonna be opposite over adjacent. Opposite over adjacent, you see. And then shift 10, 2 over 3. I mean 2 over 6. And then what's the angle here?
It is 18,43.
18,43, which is kind of believable because this angle does look kind of, you know, small. 18,
Oh, I took it off.
Oh.
It's 18. Let me quickly check again. 2 plus 6. Okay. It's 18,43.
Thank you. By your donkey. So there we go. So that's gonna be that angle there. That's the original inclination of the roof. Then it says calculate the inclination of the new roof with the horizontal. So this one is kind of dumb because it's just going to be the 18 point something plus the 16. You see?
Oh, okay.
What is the inclination of the new roof with the horizontal? So it's our 18 point something that we worked out now, 18.43 plus the 16 there. And then that will be that. So for question number 3, we can see it's going to be 16 plus the 18.43, which is like 18.43 plus 16. That's like 34.43. There you go. That's the way we like it.
Mm-hmm. Okay, understand that. Let me see. Let me read the next question. See if I can figure it out after doing this. Let me just check. A K transporting my